Most of the time, it's impossible to give thermodynamic properties in the form of equations. So we have to use thermodynamic property tables. So in next slide, we are going to take an overview on thermodynamic property tables. If you go to the end of your textbook, you will find out that there are plenty of property tables. In this lecture, we are going to focus on few of them, and I have highlighted the property tables that we are going to focus on. Basically, there are two liquids that we are going to counter again and again in this series of lectures, that is water and refrigerant 134A. In your textbook, you are given two sets of tables for these two liquids. If you understand water tables, you can easily understand refrigerant tables. So for the moment, let's focus on water tables. It is easy to connect the problem to thermodynamic property tables using a TV diagram. So let's revise the TV diagrams briefly. In a TV diagram, you have this vapor liquid dome, and towards the right hand side of the vapor liquid dome, you have compressed liquid. On the vapor liquid dome right hand edge, you have saturated liquid. Inside the dome, you have saturated mixture. On the right hand edge, you have saturated vapor, and outside the right hand side, you have superheated vapor. Same principle applies for PV diagram. The only difference is, instead of constant pressure lines, you have constant temperature lines. So let's discuss these three tables on detail. The first table that we are going to discuss is saturated water temperature table. So this table is applicable when you are operating in or on the vapor liquid dome. So if your mixture is saturated liquid, saturated vapor, or saturated liquid vapor mixture, you are going to use this table, specifically if you are given the temperature in the problem. So this table lists temperature on the right hand side, and for each temperature listed, you are given the saturation pressure, and also you are given 4 other properties: specific volume, internal energy, enthalpy, and entropy. For specific volume, as you can see, there are 2 specific volumes listed: VF, which is saturated liquid specific volume, and Vg for saturated vapor specific volume. VF, saturated liquid specific volume, is applicable when you are operating on the left hand side edge of the vapor liquid dome, and Vg, the saturated vapor specific volume, is applicable when you are operating on the right hand edge of the vapor liquid dome. When it comes to other 3 properties, you can see there is an additional column in the table. This UFG figure is simply the difference between UF and UG values. We have to repeatedly calculate this value if it was not given. To make things easier for us, they have given this UFG value. Second table that we are going to discuss is saturated water pressure table. This is very similar to the table that we just discussed, temperature table. The only difference is right hand side column is pressure instead of temperature. So in the problem, if you are given pressure, you are going to use this table. We are going to discuss these 2 tables further in our next slides. So even if you don't understand these 2 tables very well, it's alright, you can proceed on the video. Third table that we are going to discuss is superheated water table. This table lists properties for liquids that are on the superheated vapor region. As you can see, the format of this table is completely different. You are given separate tables for each pressure, and for each of those pressures you are given temperatures, and for each of those pressure temperature combinations you are given volume, internal energy, enthalpy, and entropy. I think it's easier to understand how to read superheated water table. So let's go ahead and discuss superheated water table